Hi, Carrie. Can you hear me this morning?
I can hear you. Can you hear me?
I sure can.
Great.
I see Chuck's in the waiting room. I will try and get things sorted here and make you a host.
Great.
Help me. Okay. Want to make co-host. There you go.
Okay.
Okay.
Got it.
I am not seeing it. I'm gonna
once before lunch and once before the end of the meeting. So, but during these Zoom meetings, the public comment, I guess, Mark, has to be submitted via email, I'm assuming, or text, but not publicly during these meetings. Anyhow, you guys, it's great to have such a wide variety of people at this meeting, and I'm kind of excited. I think this is kind of a new day for us for sure. And you guys will get a feel for that, I hope, as this meeting progresses as far as board engagement, board involvement with the science. I think I'm going on 7 years on the board, and really it feels different to me. And hopefully we can have some kind of a dialogue afterwards, either individually or as a group too, to sense if you guys have the same sense that I do as far as a new day. But a big part of that new day are the new members. And for us as a board, I think we saw this at one of our recent meetings on trying to get a vote on a mission statement change. It's hard to enact our work as a board if we don't have a full complement. And we need all the board members present as possible. And we need all those positions filled. And my compliments to Kurt, Director Melcher, for recently filling these positions. So just real briefly, I'm going to do a brief introduction. And as you new board members feel compelled, you're certainly welcome to give us a little bit more background, either on your careers or on your personal interests. But I'll start off with Derek Wall. And I'm not 100% sure if Derek is part of this right now, Carrie. I think Mark said he's up commercial fishing in Bristol Bay, so he may or may not be a participant of this meeting. But Derek is a fifth generation commercial fisherman and has been a gillnet advocate throughout the fisheries reform, the Columbia River fisheries reform process. And he's, like I said, presently fishing in Bristol Bay, but I'm sure that he'll be able to give us a little bit more of his background. But it's an important voice, you guys. And when I came onto the board about 7 years ago, Spuds or Suds, great guy, he was leaving, and I even asked him, he said, yeah, this will be my last meeting, Brad. And I said, oh gosh, sorry to see you go. Why are you leaving? He said, well, the Coastal Caucus want to make sure that the OHRC board wasn't going to do anything that would harm our fisheries. And I can tell you're not going to do. So it's a long drive for me from Astoria. And so I can understand his reasoning, but again, all the stakeholder groups that have been designated for this board are really important voices throughout the state of Oregon. And it's important that all those stakeholder groups are represented. And I'm looking forward to Derek's contributions on behalf of the commercial fishermen. Next is Travis Mackey. And Travis is a fisheries biologist with the Cow Creek Band of Umpqua Tribal Indians and has represented tribal interests in various fisheries, conservation, and habitat management forums. And he'll be obviously taking the position that was filled by Maureen Hess before her retirement. So, hey, Travis, welcome to the board.
Thank you. I'm glad to be here. Appreciate this opportunity.
And then the next member, I think we heard from Tom. He's probably more on his phone than he is on Zoom, but Tom is an author and an avid fisherman, and he'll be representing the wild fish advocate position that Kyle Smith vacated when he retired last year. So Tom, a really hearty welcome to you as well.
I'm glad to be here. Thank you.
Yeah. So we do have a fairly packed agenda. These 2 or 2.5 hour meetings get pretty tight, you guys, but we definitely want to encourage your input. We want to embrace as much of your valued comments to share with us. And I think there's going to be a couple of agenda items in particular today that definitely will stimulate your response. I guess the only thing that I would ask is just try and stay targeted, try and stay on focus on what we're talking about to move the agenda along. We've all got copies of the March meetings, Carrie's exceptional work of recapping every word that we say in these meetings and making them public. And so at this point, I would entertain a motion to approve those minutes. Is there a motion?
Yes, Scott, I'll make a motion to approve.
Thanks, Scott. Is there a second?
It's a second from Lindsay Ball.
Thanks, Lindsay. Verbal vote. All in favor of approving the minutes as submitted, say aye. Aye.
Aye.
Aye.
Any opposed or corrections? Okay, the minutes stand approved as read. Thank you. Next, we will move into a facilities update from Jen. And hey, welcome back, Jen, and congratulations on the new baby.
Thank you. Yeah, so the guys did a whole bunch of stuff while I was gone, and we'll kind of recap what has changed. We, as far as staff goes, no major changes other than I'm back and Eric is gone, and our host left yesterday. He'll be back next January, and we really appreciated him. He's been here since November, so he was really great. Our intake project, again, nothing major going on there. We are working on an R&E grant. I've passed that on to Brent, who is taking it to Scott as part of an ODFW package to look for funding to extend the apron so that we don't see damaged fish next year. Which I guess at this point it would be the year after. We wouldn't be able to do this work this summer. On the landslide, we pretty much have had no movement. Eric came out and did a drone fight last week. Not much has changed since the major stuff in December. It has been pretty windy and some of the trees have been knocked over. So there's that, and it appears that the county is anticipating this to last for quite a while. And I believe they're up there pulling the bridge out for the near future right now. Maintenance stuff that we're going on. The simulated streams are done being fenced. They look really good. We're still working on getting a siren for the landslide alarm and getting that installed so that it's ready, but we have some time there. I've submitted a work order to engineering to get the pole barn roof fixed. We noticed that some of the metal on that is starting to come up and blow around, so trying to get that fixed. We've screwed it down temporarily, but everything's going to need a replacement. The guys while I was gone got the alarm system put in and it's functional. We're using it. It's really great. We have a couple of modifications for Perry to make when he comes out to do the siren, but otherwise, you know, it works beautifully. We did our annual pressure washing and cleanup down around Thistle. This last weekend was free fishing weekend. Obviously, we didn't host an event, but there were people around, so we still wanted to make the pond look nice. We're replacing our Cub Cadet. It sustained a little bit of damage, and so we're going to be getting a Kubota side-by-side diesel in July, once we get into the new biennium. When we did the fencing, the contractors asked us to clean out the settling pond that is right above the simulated streams. And so we took that opportunity to drain it down, try and come up with a more efficient way to remove the cover from it and do that work. And then while it was down, we started digging out any of the sediment that's been put in there. The purpose of the settling pond is to basically keep as much of the sediment that comes through the river out of our raceways and ponds as possible. So it's designed to be a collection point. So we cleaned that out. And we also found that there are a couple places where the pond liner has detached from the wall of the settling pond, and it's causing gravel from outside the wall to suck down into it, basically making a little sinkhole. So we're going to be looking at getting some grout to fill those areas so that that stops. If we can't get it to stop leaking that way, then the next steps are either to try and grout under the whole thing or take it out and put a whole new settling pond in, both of which are pretty expensive options. Coming up, we're going to be doing the things to maintain the facility, make it look nice. We've got every 3 years, Oregon State has their animal care areas certified by a national accreditation. And that was supposed to happen last fall, didn't happen because of COVID. So they're coming in July. So we'll be spending time weeding and cleaning up the facility and pressure washing buildings and things to make it look nice, as well as cleaning up inside. We also are now open to visitors on the outside areas. So that's another reason to kind of spend extra time on the landscaping in the facility. And then one of the last things as far as maintenance or facility upkeep goes is we made the decision to rename the meeting room for David. So we're working on getting a plaque for the room and getting that set up and looking nice. And then we'd like to do a dedication later in the fall before Pat moves out of the country. So that's something we're working on as well. The fish trap season is over. We again had a really great Chinook year with over 600 fish. Coho was better than average with 460 fish. And our steelhead year was pretty bad. We had just over 50, and 25% of those were hatchery strays. The work on the apron of the dam should help with that. Also, we've watched fish jump over the dam, particularly the steelhead can clear that. So we think that if we get this apron put in the next couple of years, that will actually help our numbers, because fish won't have a way to pass upstream unless they go through the trap. For our operational research, we're doing a lot of different things this year because we don't have really any outside research this year. So one of the things we're doing, surrogate project, a few years ago showed that with Chinook, at least smaller eggs in a female would develop more quickly than the larger eggs in that same female. And they decided large eggs, small egg size by weighing each individual egg, drying it a little bit, weighing it. That is time consuming and not something you can do with large numbers of eggs. So we talked to Jen Sorter at a trade show a couple years ago and asked them if they had any ideas on how we could do this a little more efficiently. And they came back with, well, we could probably make different size sieves and we can drill holes that are 0.5 millimeter different. And if it goes through, then it's a small egg. And if it doesn't, then it's a large egg, sort of a thing. But in between that conversation and now, they have designed a system where you can put eggs into it. You can program the computer to split it at a particular size, and it takes a picture of each egg, measures it X and Y, gets the average of the diameter, and then decides where to spit it, either above or below that. So they've designed a really interesting piece of equipment to meet that need. We used that this year. They sorted the eggs, and then we're going to run the fish that way this year. Small ones together, large ones together, a group of mixed, and see if we can do anything about fin nipping or show anything about growth rate. Those fish just ponded this last week. So we're all of a sudden getting ready to start going on this stuff. We also had other projects. going to repeat the structure project that we did in 2019. We found that we got bigger fish, better fish, leaner fish on less food. And the only downside was that we got ick quite heavily. And so we are hoping that if we pull those structures out in the late summer and early fall, that we can kind of avoid getting that disease issue and still get the positives that we got. We're also going to look at flow and see if that does anything. If fish are busy swimming around, are they less likely to chew each other? We did a feed project last year, 7 days a week versus satiation feeding. This year we're going to do that again, but the 7 days a week fish will also be fed 4 times a day to see if that makes a difference. And again, we're looking at conversion ratings, fin condition, condition factor, length, weight, fish per pound, all those different things that matter in a hatchery. And then we're also working on a project with the surrogates. They came up with a pilot project to look at fin nipping in their projects. They raise steelhead over a 2-year time frame. And they end up getting a lot of fin nipping because, I mean, ODFW raises steelhead in a year to a larger size than surrogates are raising their fish in 2. So we're holding feed quite heavily on those fish, and so they nip each other. So they've designed this pilot study to try and identify when that nipping is happening, and then to see if there's any bacteria that is contributing to either causing the nipping or exacerbating it afterwards. And so to do that, we're looking at looking for fin damage and photographing the fish. We're saving them for histology. And then we're also clearing and staining all of these fish, which is going to allow us to see the bone structure and the cartilage structure of the fins to kind of see, you know, is the damage superficial? Is it down into the fin rays? Does it happen when the fins are cartilage? Does it happen when they're bone? You know, things like that. So we have a whole bunch of jars and a variety of steps of that process that we're keeping track of. And then we're continuing to work through the data from last year's projects on the opercular deformities and feeding methods. And then my last little bit here is education and outreach. Obviously, we haven't been doing a whole lot of that. We're still closed to large groups and the building is still closed to visitors. We have an outdoor information kiosk. We've got some signs for that to direct people there, just so that people can get information on the facility and regulations and things that we have inside the building, but that they can no longer access. But they are allowed to be outside the facility now. And then Craig and Brian did some dissection classes to the high school students at ALC. They went to ALC school in April. And they enjoyed having the opportunity to go and teach. And the students enjoyed the class as well. That's what I got.
That was comprehensive. That was great, Jim. Thank you very much. Any questions or comments from anybody in the audience directly to Jen regarding the facility? So I would like to make one comment. And again, thanks, Jen, for that report. You probably heard her mention the term operational research. And for those of you that are new board members, and certainly for those of you that are in the public audience as well, the 2 baskets of research that OHRC performs are operational. I also call that tactical, short-term, and those are focused on improving hatchery practices. And then the bigger picture ones, the strategic research, are the 3 big projects that we talk about all the time. domestication, mate choice, and homing. And those are more focused on understanding the differences between hatchery and wild fish so that we can manage those differences. So anyhow, those are the two big baskets, operational research and then strategic research. And we're going to be talking about research quite a bit later on today. So I wanted to clarify that for you. Okay, if there are no further questions of Jen, we'll just keep progressing on the agenda then. And Mark, it looks like you're going to be up quite a bit today, but your first shot here is the ODFW update.
Great. Thanks, Brad. I'm working through a couple of laptops here this morning. So hopefully this isn't unsettling to anyone. I apologize for the echo. Can everyone hear me fine?
Yeah, you bet.
Okay, great. So first I'm going to kick off and just talk here a little bit about our budgets. This is a really busy time for us as we transition into the new biennium. So I have been working closely with folks both on the ODFW and OSU side, as well as some of our subcontractors that do work through the center. And of course, we need to take a look and be very careful about budgets as we approach the end of the biennium, that we don't overspend. And the good news on that is that ODFW saw extremely strong recreational license sales throughout the course of 2020. It was, I guess, one of the bright spots of 2020 for us. And our economists now project that we'll finish the current biennium with revenue for the research fund totaling just under $1 million, maybe about $1,010,000. And this exceeds the commitment that ODFW made at the beginning of the biennium, which was $800,000. And so that leaves a cushion that can carry over into the next biennium of about $200,000. And that'll help to support our research moving into 2021 and on into, or through 2021 and on into 2023. So that, we look like we're in good shape to finish out this biennium. Late last week, I received a forecast, another report from our economists at ODFW, and they currently project revenue for the coming biennium to land within the same range as what we've seen during this biennium, somewhere between $960,000 to $1 million. So really close to where we're looking to be at by the end of June this month. So while both of these projections fall short of the initial 1.2 million dollars that we'd expected per biennium, as folks will recall, that was the initial commitment. You know, our researchers have done a great job to adjust to the new, to the fiscal reality of revenue that we're able to generate for the dedicated fund, and they've been spending appropriately. So they're not exceeding the commitment, and in fact are actually preserving some carryover funding. I'm now working with ODFW's contracting services to amend the agreement that supports OSU's work at the OHRC. But currently we're doing this at a significantly reduced level relative to past years, at least at the start of the biennium. So as of July 1st, ODFW will have committed $635,000 of our projected $1 million of revenue, of income, to research that's currently ongoing at the center. Obviously, that leaves a significant surplus of about $400,000, which we can then allocate either to our ongoing research projects or to new projects as we identify and prioritize those and during the course of the biennium. And I'll revisit that topic with a lot more detail later in the meeting. But maybe I'll just stop there with those numbers and take any questions if board members have questions.
Hey, Mark, this is Andrew. I had a question. Thanks for the update. That's really helpful. And you mentioned we might dig into this more later in the meeting. So feel free to defer this question if that's more appropriate. But I think if I recall, it was at the start of this year or going into, or maybe it was about a year ago. I thought there was a period in which the researchers were asked to reduce budgets based on the revenue situation previously. And so I was just wondering if consideration for that balance of 400 might be restoring any previously adjusted budgets, if I have that right. So thanks.
Great. No, good observation. So at the beginning of the current biennium at 2019, we researchers to curtail their budgets based on our revenue forecast, which was going to fall well short of the $1.2 million that we previously promised. We actually ran into the red in the biennium prior to that, and in the 2017-2019. And so lessons learned, we adjusted our commitment. So the researchers certainly curtailed their budgets, and then as it turned out, yes, our revenue came in, as I'm reporting today, higher than we had projected back in 2019. So this has been a really difficult time to navigate and forecast, right? As we've moved through this pandemic and human behavior and licensing, this is uncharted ground for our economists, obviously. So it's a nice surprise that we've come in over our forecasts. And yes, that generates a budget surplus. And yes, it's absolutely on the table that money can be used to compensate for the savings that our researchers help to generate, through cutbacks in their projects. But in context of the larger picture and where we want to take the center, we're at a moment where we're taking pause, taking stock. This was the evaluations that we conducted at our last meeting played into our decision here today to commit yet even less at the beginning of the biennium. However, we can then expand that commitment moving forward. And I'm going to talk about the process of how we do that later today in the meeting. Because we can amend this contract, which I'm working to amend now, and has to be amended by the end of this month of June. That can be amended yet again later in the year or early next year to restore full funding to our ongoing projects or to fund new research as it becomes prioritized. Does that help answer your question?
Yeah, that's really helpful. Thanks, Mark.
Mm-hmm. So I guess we're going to be a little bit ahead of schedule today, Mr. Chair. I have nothing more to report in terms of the ODFW update today.
Okay, great. Thanks, Mark. So quickly, before Sean steps in for Selena, let me just do a quick background for those of you in the audience that may not be familiar with either Sean or Selena. Selena Heppel, Dr. Heppel, is the director of the fisheries department at OSU, and she was David's boss when David was a professor there, and she still is in that role. So she's heading up a committee to search for the new director to fill David's role here as director of OHRC. And she's absent today with some educational commitments. And so Sean is going to be stepping in for her. I know a lot of you in the public audience are familiar with Dr. Sean Clements, but just briefly, he is the Assistant Fisheries Director for ODFW. Those of you who may have remembered Bruce McIntosh before he retired in December, and Sean is filling that role right now. So Sean, filling in for Selena, is going to give us an update on the director search for OHRC. So Sean, the audience is yours.
Thanks, Brad. Yeah, this will be pretty quick too. So the committee's met once and to draft the announcement, and then there's been some back and forth over email with HR at OSU to develop the position description. And I think in the end, the description was split into two parts. One, 6 month annually, which covers the director duties, and then the other 6 month annually, which covers the academic duties. It seemed it's one of those bureaucratic things that we just have to jump through the hoops to get there. It's not optimal, but I think it's where we're at. And so given that just got approved by HR last week, I think the announcement will be going out pretty soon here for the search. And that's kind of where we're at.
So Sean, do you have the list of that committee in front of you there? I think it would be interesting for those of us that are on the board, and certainly make that a public record in the minutes here of who populates that search committee.
I don't have it in front of me, no. I know from ODFW's perspective, myself and then Ryan Couture, who was the previous hatchery manager at the OHRC, are on that committee, and then it's being headed by Lisa Balance, Dr. Lisa Balance from the Marine Mammal Institute, who's also in a similar position to David, not shared with the state though. I can't recall who all the other members are. We've just had discussions on email, but I think Selena could probably follow up with that list.
Okay, thank you for that. Yeah, I'll follow.
This is Carl. I think that Brian Sidlauskas is a member of that committee as well.
Yeah. And who is he?
And he's a professor in fisheries.
Okay. So maybe we need a little bit more clean outline of who's on that committee. So I'll follow up with Selena and make sure that we do get that in the notes so that it's transparent and it's in part of the public record. Thank you. Okay, so let's see. The next item is Sean. It's still you. The mission statement update.
Sure. Yeah. So last meeting, the board during their discussions discussed a proposal to revise the mission statement of the OHRC that was presented by Scott Starkey. There was some brief discussions around that, resulting in a recommendation to the director, which is currently Mark, to alter the mission statement. ODFW and OSU reviewed that recommendation and the statement. And in our review, we considered the discussions that we heard on the day, both from folks that supported and opposed the change. We also considered conversations with Scott that Mark and myself had subsequently. And then we also looked at the sideboards from 3 of the guiding statutes here, which is ORS 498-831, which describes the activities that the OHRC shall conduct, as well as ORS 506-109, which is ODFW's food fish management policy, and ORS 496-012, which is our wildlife policy. Additionally, we tried to avoid any kind of redundancy in the statement just to keep things simple. So the primary issue we heard on the last board meeting and in discussions with Scott and others is a belief or a sentiment that the mission statement didn't accurately reflect some of the value that hatchery fish can provide and was a bit too negative. There weren't actually any changes proposed in the mission statement that got to that point. So we added some language in both the first and last paragraphs to address that. And Mark, I'm not sure if you can share that, kind of the proposed or the version that we're talking about adopting here. So we added language to discuss the benefits that hatchery fish can provide and the value of hatchery fish, as well as the desire to educate Oregonians about the benefits of hatchery fish. There was two problematic statements in the proposed version. The first having to do with the mission being to maximize harvestable fish or achieve maximum fisheries. This is somewhat problematic as it would come into conflict with two of ODFW's guiding statutes, which are ones I mentioned earlier, which talk about optimizing the use of fish, food, fish, and wildlife, recognizing that there are other values at play and that we have to consider this balance. And then secondly, the statute that guides the OHRC activities are already paraphrased in the existing version and don't talk about maximizing harvest. The second problematic statement was around defining measures that when hatchery fish no longer pose a problem based on a pedigree study in each watershed. We've had discussions about this previously, and I think one of the issues is that this is logistically unfeasible for both the center and ODFW given current resources. We're talking about putting some kind of weir on every river system coast-wide and pulling out and seeding hatchery fish at different levels and then recording runs for quite a long period of time, which just we don't have the resources to do. Additionally, I think if the board feels that that is an important thing to do, that's likely best achieved through looking at the strategic direction that the center is going to take and perhaps taking advantage of that opportunity. I would note though that the role of the OHRC is to perform the types of activities that are outlined in statute, which are then intended to inform the policy decisions that ODFW makes. Science can't really tell us where to draw that line. That's a policy call, but it can certainly inform both sides of the argument there. So based on those three considerations, we developed a revised mission statement, which is at the bottom of the page here. The red text is the new text. I recognize that this doesn't go as far as some folks would like, but hopefully you can understand our rationale. And hopefully when this is put together with some of the changes that we're instituting with the board and both the research and some of the focus, the package comes together to kind of meet that need. So that's it in a nutshell. Happy to have any discussion.
This was definitely one of those two areas, you guys, where I thought we would have robust discussion from the board. So please don't be shy.
Well, but it's about the only discussion I have is it's, you know, the motion as we made it has been so watered down that it's doesn't even make sense to bother changing from where it originally was, as far as I'm concerned. Clearly the ODFW OFSU people, they interpret the intent of the law different than a lot of the fishermen and probably some founders of OHRC. But like Kurt said in our meeting, if you don't like the way we interpret the intent of the law, you better pursue a new law to clarify it. And so I suppose that's the direction that we need to go, because this mission statement change is pretty meaningless the way it's redone. But I understand where ODFW and OSU is coming from, but it's just not coming from the same place we are. That's about all I have to say.
Thanks, Scott. No, your insights are always important. Further discussion from the board. Any other comments on the changes to the mission statement? Move on with the mission statement. So I've had a lot of dialogue, I guess, kind of behind the scenes with Sean and Mark, a little bit with Cedric and Kurt too, and Scott. You and I are coming at this we're probably looking at the same outcome, but coming at it from a different approach. My sense is that if we're disciplined from the science, that the mission gets us where we need to go, because it talks about the co-equal objectives of fisheries and protecting wild genetics, and it's treated co-equally. So for me, if they are equal, then the mission statement doesn't have to be addressed. The problem for me is, so I think the mission will get us where we got to go. And I'm going to say this, and I know there's further discussion down the road when we get to the evaluations. I don't think the science gets us where we got to go, and it hasn't gotten us where we got to go. And so, for me, you guys, I look at the science as discovering a cure for cancer, as discovering a vaccine for a worldwide virus that kills people. You know, those are positive outcomes of science. So the outcome of our science can't be just status quo. And the outcome of our science can't be, you know what, we can't make more hatchery fish and protect the wild genetics. That can't be the outcome. We're smarter than that. We can create all kinds of phenomenal objectives through science. So the science has to get us where we got to go, and where we got to go is more hatchery fish, protecting those genetics. And the science can't fall down, but I'll tell you, it has fallen down. It hasn't gotten us where we got to go. So that's my beef, Scott, on this whole process. It's not the mission. I think the mission, if you just leave it alone, can get us where we got to go. And then the next discussion will be on the science, and we're going to have a robust discussion on that and research ideas in the future. So anyhow, any other comments now on Sean's amendments? These will go into effect and they'll be posted on the website. And again, Scott, I don't have the objections that you do to the mission statement. My objections will come much later and they'll become much stronger. But right now, the mission statement, I believe, gets us where we got to go. Any other comments? Carl, I know you're always good for comments on this. Anything you'd like to add?
I'm just glad that the word maximize was taken out. Like I mentioned last time, in fisheries, maximize has a certain connotation. If you want to maximize catch, you don't even allow recreational fishing. You know, you put gill nets across streams, you put traps across streams, you know, that sort of thing. And so the word optimize is, in a fisheries context, is the appropriate word.
Hey, Brad, this is Andrea, and just a few comments. And thanks for the discussion. I guess the mission statement, for what it's worth, the mission statement looks as proposed. The revised version looks fine to me. I agree with your points about recognizing co-equal goals, and also just thinking about the role of the center as a research center, and thinking about a more narrow focus of what that role is. You know, when it comes to the numbers of hatchery fish in Oregon streams and that management, I think that's ODFW's job. The center provides the information to help make those decisions, but as I see it, the mission statement as proposed, you know, provides the right level of focus to what more precisely the center's role is in kind of the broader context. So yeah, some thoughts there.
Hey, Andrew, thank you. That's an important clarification, you guys, for sure. And I know that I've been a broken record throughout my time on the board, that you're right, absolutely. The facility is not about policy. And every time that we try and bring up questions about policy to put more hatchery fish in the river, that's not the right forum for that at all. You're right. This is the science, and the science basically has to get us to the point where we understand the differences between hatchery and wild fish better than we do now, so we can manage those differences. That is the mission of the facility. You're right. Putting more hatchery fish in the rivers right now, Andrew, not part of the deal. Yep, you're right. Absolutely not. The science to get us there, though, is because the science has gotten us to where we are now. It was the science that said, hey, you know what? Reproductive success is impaired when hatchery fish mate with wild fish. Those weren't policy managers that made that discovery. Those were scientists. So the scientists put us in this conundrum, and the science has got to get us out. It's got to get us to the point where we can make more hatchery fish and protect wild genetics, the diversity of the wild fish. But you're right, the function of the facility is the science. It's not the policy.
I know, Brad, I'm probably beating a dead horse to talk about this, but the goal of the research center is to, according to ODFW OSU, is to find the differences between wild fish and hatchery fish and manage those differences. But how can you manage something and maybe reduce those differences if you have no measurable goals? You don't have any measurable at all, and they seem to be wanting to avoid having any standards of measurement. I mean, we need to know where a hatchery fish is and where a wild fish is, and so if we can minimize those differences, but heck, we don't have any standard of where we are now and where we want to go, other than kind of a flaky fitness thing. But anyway, that's the way it is.
You know, Scott, certainly I am sensitive to your frustration. You know, on the one hand, we do hear that PHOS is a risk management metric, and that we hear that relative reproductive success is a risk. And then on the other hand, when we bring in special speakers to talk about relative reproductive success or PHOS, they leave our meeting saying those are not relevant metrics to use. So on the one hand, those were the metrics that got us where we are, but now to get us out of here, we can't use those metrics. So you're right, it is frustrating for sure. I'm not sure.
Hey, Brad and Scott, just a couple of things here. I mean, I think the body of science that got us here is it doesn't just boil down to one person saying that PHOS is not a viable metric. And the way we look at things here is we know from the body of science that relative reproductive success drops anywhere from 0.5 to I think about 0.75 or 8, depending on the species and the location. And that's been pretty consistent across those studies. The center, through its research, if it can move that needle anywhere closer to 1, that allows more opportunity for hatchery fish to be introduced into the system because you're reducing that risk. So if you can move it from 0.5 to 0.55, that opens up some opportunity. You can move it from 0.5 to 0.9, that opens up a lot more opportunity. So ODFW is all about managing that risk and the balance. And that's a continuum. So we recognize that through this research, we might be able to move the needle somewhat, but not all the way. And that still opens up opportunities. And that's really what we're shooting for, is to move along that continuum closer to 1. It doesn't have to get to 1 before we have more opportunity. And given that RRS will change annually in each system, it's just not feasible to do that and establish some kind of baseline. We just need to body of science to say that we've moved from, say, 0.5 to 0.6 or 0.7.
Well, Sean, in the Coos River, what is the RRS of wild fish and what is the RRS of hatchery fish right now?
I think, Scott, that's what I'm talking about. We don't have those values for each system, but the body of science will say that it's going to be somewhere between the extremes that we've seen. That's just how science works. It doesn't give you a value everywhere for every time. It says, in general, here's what you can expect.
I'll echo those thoughts, Sean. So again, you know, we might consider an analogy here. What would be, we improve fuel economy on vehicles, right? And we don't set a limit on how well we can improve that, right? So we can get it from 30 miles to the gallon to 50 miles to the gallon. When do we say it's good enough? Better is better. And so if we can improve the fitness of our hatchery fish, move them from 0.5 to 0.75 to 0.8, 0.9 to 1, or even for that matter, higher than wild fish, that's improvement. And we'll take all the improvement we can get. And it's my belief that actually we have multiple mechanisms affecting the fitness of hatchery fish. And so to make those incremental improvements, we're going to need to make changes across a variety of our practices in the hatchery system. This might involve mate pairing, might involve enriched environments where we reduce domestication effects and more. So each one of those changes, we hope can improve the fitness of our fish a little bit. And in some cases, we'll be able to measure that fitness. Fitness studies are complicated and they're expensive. They require genotyping and parentage, and they take time because they occur across generations. And we have to be able to intercept both the parents and their offspring in those systems. We can do that in some places. We can't do that everywhere. And so just as with so many things, we have to be able to accept proxy estimates, right? And the estimates that we've gotten from other systems that range from Alaska to Oregon to Idaho and California, Washington State, the arrows are generally all pointing in the same direction. And so there's plenty of good reason to believe that proxy estimates from other systems and other species are applicable to those systems where we can't actually measure fitness. That said,
One more,
which
comment.
we can
I can't understand why you avoid the measurables. I mean, you said the body of science was adequate to curtail hatchery fishery, but you can't use that same science to set a standard to when you have minimized the risk. I mean, if do we have to be 1-to-1, or can we be 7-to-1? Are you going to set a goal, a measure of when we've adequately improved and how to get there?
I think, Scott, that's kind of, I'm not sure if we're talking past each other here, but as both Mark and I have said, any improvement can result in a change in hatchery practices. So if through science, we can shift that needle from 0.5 to 0.55 or 0.6 or 0.65 or whatever it might be, that opens up opportunities. Our goal is just to shift that needle in any way we can, and that opens up opportunities. We don't have to get to a set number before we can make those changes. We just have to move that needle.
And in reality, it's impossible to calculate those numbers because there is no baseline for RRS or fitness or any of these other terms. And that's because the environment and the biology is so stochastic. It's like coming up with an average weather and then saying the weather today isn't average, therefore there's something wrong. But it's all that variation that actually constitutes the average. So it's really the direction of the change that matters rather than what the actual number is.
Yeah, well, that's what I was expecting. So anyhow, and Carl, yeah, thank you for that. I mean, it's the direction, like Sean said, that we're after, and Sean used the phrase "improve the fitness of hatchery fish," and so for me, Scott, the mission statement can stand alone; it gets us there. But does the science move us in that direction to improving the fitness of the hatchery fish? I mean, that's the cure for cancer, you guys. That's the putting the guy on the moon. The science is going to get us there, improve the fitness of hatchery fish. And so that to me needs to be our focus as a board, to influence the science to get us there. Okay, any other final comments on that before we move on to the next item?
Brett, I'd just add that I think this has actually been a very healthy and necessary exercise for the board to take pause from time to time and consider the mission. We need to make sure that our mission is pushing us in the right direction and that we're abiding by the mission. So as you can see there in the red letters, Sean, Selena, I, and others, we came together and we heard the recommendations from the board and agreed that there was a greater emphasis on risk and relative to the value of hatchery fish stated in the mission. And so the changes that we've made have been indeed in response to the spirit of recommendations that were brought forward by the board. So I do appreciate the board's attention to the mission statement, and please know that we consider those in making in revising this mission statement.
And I take that spirit too, Mark. I totally understand the spirit with which you guys made those changes. Jack, we haven't heard from you, or Lindsay. I mean, is there anybody else on the board? Ted, do you guys have any comments before we move on? As far as the mission statement, I know we're going to talk more about the science. It's hard not to kind of combine the two, though, when we're talking about the mission. But any other comments from you guys that we haven't heard from yet today? Please speak up now and share your thoughts on this. This is pretty important.
Brad, all I would say is that, I understand that we had one presenter that said relative reproductive success is not a good way to measure fitness. He said that because relative reproductive success, individual relative reproductive success, which is the measurement we use, doesn't transfer to the population level. And I don't know how you get where you want to go if you're using a bad standard. And he's not the only one that said that.
So again, Jack, my response to that would be, yeah, I mean, there's a big difference between individual level and population level. But in listening to Mark and Sean and Carl, if the science that comes out of OHRC moves the needle and shows that we've improved the fitness somewhat, whatever that is, from 0.5 to 0.55 or to 0.7, that's progress in the right direction. That then could influence policy. It's not our job to make policy at OHRC.
I completely understand that, Brad. But so I guess that's why I didn't comment, because what the mission statement says really doesn't matter.
Well, it does matter. I mean, the mission statement definitely is the foundation. It's the blueprint for the science, Jared. So if you don't think it matters, we need to kind of drill down more on why you think the mission statement doesn't matter.
It doesn't matter because the research we're going to do no matter what the mission statement says.
Yep, that was the old, yep, that you're right. That's the past 15 years, buddy. But I hope what you're sensing right now today is a change in spirit that Mark just talked about. I mean, yes, you're right. That has been our history. We're just going to do what we're going to do. And we're not moving the needle. We haven't moved the needle. But I'm telling you, today feels to me like it's a new day. So the mission statement is important because it'll be the blueprint.
I hope you're right. I'm skeptical.
Okay, this is good though. Any other comments before we move on to Dr. Reed? Okay, Amy, I guess you've got a report for us on vitamin deficiencies in hatchery salmon, and that should be of interest to all of us. So Dr. Amy Reed, if you wouldn't mind sharing your study, I'd appreciate it.
Howdy, everyone. I don't see myself, but I hope you guys can all see me.
You do.
I'm sure that all of you know me. I've been around, I work for ODFW. I'm the Senior Fish Health Specialist, Aquatic Veterinarian, and Manager for the Fish Health Program at ODFW. I've been in the position for about 3.5 years. And just briefly, I've been an aquatic animal clinician. I went to UC Davis for vet school, and then I was at OSU for 3.5 years doing a PhD in fish viruses. So I've been enjoying my time here at ODFW and applying some of my kind of whole health approach to some issues that we struggle with while propagating both wild and hatchery fish. So what I'm going to talk to you about today is an issue with vitamin deficiency that some of you might have been familiar with. It's kind of been a hot topic in the news lately. And I am just going to keep on going with this talk. And I know that there's only been 15 minutes slated. it's very likely I'm going to go a little bit over because I want to also leave time for discussion. I'm going to share my screen with you and just talk a little bit about why I'm looking at nutrition in Oregon salmonids, and then what we're seeing outside of Oregon, and maybe what can we do about it. So let's see if I can do this here. Mark says my mic is kind of hot. Okay, I'm not quite sure how I can turn that down. I can
Maybe if you, I'm not sure, but maybe if you tried turning down the volume on your speakers, maybe would a little less feedback. I'm not sure how to
try that. Yeah, I can also just calm down a little bit and speak a little softly if you guys can hear me okay.
No, I think this can work fine.
Okay, great. Here we go. So I'm just going to go ahead and share my screen with you guys. And some folks might have seen this before, but I think that what might be really interesting is going to be some discussion afterwards. So
I made you a co-host, Amy, so I believe you should be able to share your screen.
let me see here. It's starting to split my screen, so I'm trying to figure out which one I can share with you all.
There you go. Yeah.
Go here. So hopefully you're able to just see my slides and not my presenter view. Is that correct?
Yes.
Yes.
Super duper. So here we go. So I'm just going to chat with you, and some of you might be familiar with some work that I started doing about 2 years ago. It looked at thiamine concentration in eggs from winter steelhead trout in Oregon. First, I'm going to overview thiamine and thiamine deficiency complex. Second, I'm going to talk about investigations into thiamine deficiency complex in fish from the coast in Oregon. And then third, if there's some time and interest, I think it could be really important to talk about clinical problems that we've seen both in California and Oregon that are associated with climate change, and kind of where we're headed as to what we can do about this issue. So to introduce thiamine, this is vitamin B1. It's a water-soluble vitamin. Thiamine is necessary for normal development of function of primarily what we think of as neurologic development. So you need thiamine in order to develop your nervous system, in order to have good muscle control, in order to develop vision, as well as ability to absorb yolk and go on to first feed. So thiamine source in nature is dietary items. So you get thiamine from your feed items. You also get thiamine from your yolk sac. So there is a little bit of an interesting, kind of not quite a catch-22, but you need thiamine to go on to first feed as a fry. If you don't have thiamine, you can't get it because you get it from your feed. So it's it can be really crucial in survival of baby fish. And so one of the reasons why we see a problem with thiamine deficiency is there are enzymes that exist in feed items that are thiaminases. And these ACE, of course, is an enzyme, but thiaminases destroy thiamine stores. I'm sorry, this says in the predator, but it should be in the, yes, in the predator, that's correct. So if you are a predator and you're eating animals that have high thiaminase in their tissues, then as a predator, your thiamine deficiency, your thiamine stores will deplete. And so we can see thiamine deficiency in animals that are feeding on these feed items. Bait fish is a significant prey item that is high in thiamine deficiency. And so we can see thiamine deficiency in mammals that eat primarily fish or even shorebirds. And this can look like die-offs with really weak lethargic fish. Some people believe this is associated with marine mammal strandings, but we see it in polar bears. We see it in shorebirds. And so this looks like lethargy and weakness. These animals are maldigested, they're underweight, they could be blind, be suffering from seizures, and potentially die. And how we diagnose this is to provide some thiamine and see if the animals respond and go back to a normal state. And it's pretty quick. Thiamine, since it's a water-soluble vitamin, it gets distributed into the body relatively quickly. Thiamine deficiency complex in salmonids has been described as early mortality syndrome, M74, or Cayuga syndrome. And this really showed up in the late 80s and early 90s in the Great Lakes, and even late 90s, where they were seeing almost 100% mortality of the fry and Great Lakes salmonids. In the fish that weren't dying, they were seeing side swimmers or spiral swimmers, weak fish on the bottom, so they couldn't swim up. They didn't have enough strength to swim up. Failure to go on to first feed, failure to utilize yolk, inability to avoid predation, blindness, and death. And so there's also been, in the past couple decades, there's been some studies as to whether or not thiamine deficient fish, if they survive their thiamine deficiency state as fry, they grow up to be immune deficient fish, because we need thiamine to make antibodies. We need thiamine to allow white blood cells to kill bacteria. And we need thiamine to counteract this oxidative stress. So thiamine can be really important. Thiamine deficiency complex can be caused by low thiamine levels in the brood stock. So if the brood stock are on a high thiaminase diet, so these fish are eating a prey item that's very high in thiaminase, that can allow the females to be deficient in thiamine stores themselves. And so they're going to hold on to as much thiamine as they need to make their nervous system and their brain work. And therefore, the thiamine does not get deposited into the eggs. So the eggs hatch thiamine deficient. These adult fish are responsive to thiamine supplementation by injection, and that can really help to get both the females the thiamine they need and to get the thiamine into the eggs. If the eggs are thiamine deficient themselves, we can give them a bath in a thiamine solution, either as eggs or as fry. But when we're talking about, see, notice I'm not calling this thiamine deficiency, but thiamine deficiency complex. And this is because there really is a breadth of what thiamine levels are considered normal, especially from like a commercial feed diet. Like what's a baseline thiamine level in order that you don't die? But that doesn't necessarily correlate with normal function. So if we have a thiamine replete, that means you have like a 100% thiamine levels for your species. You function normally. And then 0 is thiamine deplete, and that means assured death. But there is this in between that's thiamine deficient, that you might not have normal function, but you might not die. And this LC50 varies really wildly by species. And there hasn't been that much research done on steelhead in particular, and because they don't raise a ton of steelhead in the Great Lakes, and that's where a lot of this data has come from. But this is a really interesting paper that looks at this LC50 when comparing different salmonid groups. And I wouldn't want to get too hung up on this, but all of this is to say is that if we review the LC50, that is the level of thiamine at which 50% of the species die from thiamine deficiency. Steelhead is significantly more sensitive to thiamine deficiency than coho, chinook, and lake trout. And really, we haven't, this is just a more sped in view of the steelhead trout. And so, you know, what we see is that if this is survivability, that there really is a variation. I'm sorry, this is mortality on the left. And so, you know, once we're starting to see thiamine in these levels of 8 and 10 in the eggs, this is when we're starting to not see death associated with thiamine deficiency in these groups of steelhead. So this is really interesting because we have struggled with steelhead in our production since we've been producing steelhead. They really have a high, what we deem as failure to thrive. And some of this just goes being swept under the rug as, oh, steelhead don't do well But I think that as a scientist and a clinician, I say, well, there's always a reason why an animal dies, and let's see if we can figure it out. So my hypothesis was that, what could thiamine be associated with this failure to thrive in steelhead? And so, what we have been seeing historically, just over the decades in steelhead across Oregon, is that there's a high mortality before and during swim up stage. There's a high proportion of underweight fish that we describe as pinheads, and these drop out. So sometimes we deem this as dropout disease. We also, in fish that do go on to feed and don't drop out, we do see a high incidence of cold water disease in these really teeny tiny fish. And in some facilities, it's that the fish get sick out of the hatch boxes and that they're going on antibiotics, which is just really not ideal. There's a moderate to high coagulated yolk and unabsorbed yolk remnant that we see that these fish carry with them. And so, one of the thoughts I had was, could this be thiamine deficiency complex? And we really didn't. We really have never looked into this. So if we're looking at these fish, right, we have a lot of dead fish on the bottom. This is a very common presentation of steelhead fry as we're ponding them right after they're hatching. And if we look at these fish, they're so skinny, right? Very, very tiny. The musculature and body condition diminishes as you get behind the skull bones, the calvarium. And so these are lollipop fish or pinhead fish. And looks like we're starting to see some cold water disease as we have some hydrocephalus starting up here. Interestingly enough, this also could be considered a neurologic deficit. And so just all of these problems with steelhead. So one of the first things I wanted to do was look into eggs and test them, and to see, could we test for where steelhead eggs lie in Oregon? Do they have enough thiamine or not? And so in January 2019, I collected and tested eggs from 26 female winter steelhead from coastal hatcheries in Oregon, 9 females from Big Creek Hatchery in the north, 10 females from Alsea Hatchery on the central coast, and 7 females from Elk River Hatchery on the southern coast. And I shipped them off. We flash froze these eggs and shipped them off to USGS in Missouri, and that's where all of the experts, the folks who wrote the books, are working. And so they tested these eggs for me, and it took many months to get my results back. But what we got back was really kind of interesting to me. So of these 26 fish, and you can see I've just labeled them like Alsea 1 through 10, Big Creek 1 through 9, and Elk River 1 through 7. 50% of the fish have thiamine levels below what was this published LC50 in steelhead. That's shocking to me. And then not only that, but if we looked at what has been posed as replete levels for thiamine, we only had what, 23% that were considered thiamine replete, which means that 77% of these fish were thiamine deficient, according to what was been published in these past few years of what's coming out for steelhead. So what we're dealing with is all along the coast, we've detected thiamine deficiency in our steelhead. So is it even possible that we're seeing some changes due to low thiamine in these fish? I think the answer is yes, but we're going to continue to talk about it. What's really interesting to note is that all of the fish that were considered replete, so we had 6 females that had enough thiamine in order to not see any loss from it, were all at one facility, and this was in the north, and this is going to come back a little bit later. So just to conclude from our egg investigation, thiamine deficiency has been detected in eggs from coastal Oregon steelhead in 2019. And then, of course, I want to know, what can we do about it? Could easy and affordable treatment be helpful for steelhead's production failure to thrive? And so what we did is we set up last year, we set up some thiamine supplementations experiments at the OHRC with some of those Alsea fish. So like I described earlier, there's 2 ways to supply thiamine supplementation for fish. We can inject females before they spawn, or we can immerse eggs in thiamine at time of fertilization. And so we chose the second, and I can talk about the first later if there's questions about it. But so we treated the eggs at fertilization with a thiamine bath, and because it's water soluble, you have to do this before the eggs get water hardened. And so what we did is we took 8 female winter steelhead and we separated out each female's eggs 50-50 into treated with a thiamine immersion bath, and 50% of each female's eggs were mock handled. We raised them in identical conditions at the OHRC, and what we looked for, so just to describe those conditions, which you all might be familiar with, but they're on surface water of ambient temperature in January. These fish were all disinfected with iodophor after fertilization, which is a standard practice for us to help decrease viral particles on the outside of the eggs. And they're treated 3 times weekly with formalin to combat soft shell disease. So that's how these eggs were handled in the facility. Here's a photo of some of the folks who are helping us to spawn and treat these eggs. And so what we split each female 50-50 and then treated half and not treated half. And this thiamine is a thiamine mononitrate. It has a pH of around 7, which is really lovely for the eggs. It doesn't cause any damage. And we did a 1-hour soak in these eggs with a thiamine treatment, rinsed them, and then disinfected them with iodophor after that. And so once they were water hardened. And then we watched them as they hatched, and we looked for differences in swim up rates and mortality rates in the first 60 days, differences in pinheads, failure to thrive, bacterial and parasitic infections, and coagulated yolk. And one of the reasons why we wanted to do this was because could we inform a standard of care for steelhead rearing in Oregon? Of course, I want to make a big difference, right? I think we all do. And so the results were not as supportive as I wanted them to, and they're still in my statistical analysis department, which is me. But so the results did not show any difference at the OHRC between the treated group and the non-treated group as far as growth rate, dropout rate, mortality, or whether or not they got disease. All of the fish did get disease. But in the meantime, we also had some side-by-sides going at a couple of facilities. And a lot of these facilities sent me their numbers that I'll also include in that statistical analysis that showed that they did have significantly less loss in fish that were treated with thiamine, in eggs that were treated with thiamine than in eggs that weren't, as well as when it did come time for the fish to break with bacterial cold water disease, either the fish that were treated had lower loss or didn't break as frequently as the fish that were not treated. So it does seem like that there is more research that needs to be done in this department. And it could be that easy and affordable treatment could be a new normal for steelhead production. Thiamine is really cheap. It costs us an hour to soak the eggs. And I'm working on a protocol right now in order to treat female adults. And so in 2020, we collected a lot more. And instead of just looking at steelhead, we're looking at Chinook, coho, rainbow trout, brook trout, cutthroat trout. And those, because of the pandemic, all of those testing in Missouri at USGS have been stalled. I do not have the results for these yet, but we're looking into it. And so this is going to be really interesting. I'm going to stop here because just to see if there's any questions, because the last part of my talk is going to talk about what we've seen in other species and in other areas. And so I'll open it up quickly to see if there's anything that needed clarification before I move on.
Thanks, Amy. Were there any unintended side effects from the treatment? In other words, you said the treatment was fairly inexpensive, didn't give you the results you were looking for at OHRC, but the field hatchery showed pretty positive results. So I guess my question when you said that was, gosh, why don't we just do it then? And were there any unintended side effects that might preclude that from the treatment?
There were no unintended. That's a really great question, Brad. Thanks. There were no unintended side effects from the thiamine treatment itself. There are a couple of things that we're cautious about. Number one, thiamine and iodine do not play well together. It can lead to mortality of eggs just right off the bat. So we always want to make sure that when this drug is being applied, that these eggs get rinsed really well before they're added for treatment. Really, one of the biggest concerns with this is applying this across the board, because of course, like I would love to just say, oh, everybody's just getting thiamine from now on, is that a 1 hour soak is really doable. Steelhead that are 8 fish at a time. In some of our facilities that spawn 200 fish a day, having a 1 hour soak for eggs can just really put a damper on their efficiency in spawning these fish. And so it can be really hard to implement an egg soak at time of spawn. I'm trying to assess how we can inject females to get the eggs the thiamine that they need so that spawning can happen as normal with eggs getting their thiamine supplementation from injecting females. It takes about a week to transfer from the female into the eggs, but that's also an option for how we can get that in, as long as we're going to have the fish on hand for more than a week or so.
Thanks, Amy.
Amy, thank you for your presentation and for joining us. This is just fascinating work, and I think actually dovetails with the mission of the OHRC quite nicely. And, you know, but I also have a ton of questions. I'll just try and restrict it to a couple. What do we know about deficiencies in wild fish, wild eggs? Is it possible to dig reds, or have we looked in that direction? So,
Mark, that's a good question. As far as I know, there's been very little research done on thiamine deficiency in fish on the West Coast, period. You know, we started our inquisition in 2019. The next couple of slides are really going to talk about why this is a big deal and maybe what we can do about it. But I think that you know, Allison Evans at OSU, she did her PhD on this, and she's in the same building in Nash Hall, and she and I have talked a lot about thiamine deficiency in fish on the West Coast. But I think she studied lake trout on the East Coast. So even though she is an expert in this, she hasn't seen any application in wild fish. My assumption is that if eggs, I guess assumption or scientific conclusion is that if eggs were deficient, those fish would not survive. However, there's also this interesting notion that, you know, when baby fish hatch, they're getting some nutrient load in their streams. And so there is thiamine in water. There is thiamine, you know, potentially in smaller particles, algae, rotifer, these kinds of things. So they could be getting some thiamine depending on their hatching environmental conditions. But the real answer is we have no idea. I would assume that if a female was thiamine deficient and she laid a red and all of those eggs were thiamine deficient, they would not fare well.
well, it seems that given the implications that thiamine deficiency can have on the survivorship, immune system, and ultimately fitness of fish, a very natural line of research associated with OHRC would be to investigate for differences in thiamine deficiency between hatchery and wild fish. So that seems like that would be great baseline information to have, so that we would have a target to shoot for.
That could be really interesting. And I think that to continue this notion, I'm going to continue as long as I'm okay on time, because this next part is going to be, I think, really provocative. I hope it's really provocative.
Go ahead, Amy, sure.
Great.
Before
So some of you might have been familiar with thiamine because it came out on the news last year when I think 2 facilities in California had a huge mortality event in their spring Chinook, where they just had a complete death of of their spring Chinook where they were seeing 5% mortality in a day. And if anybody called me and said I lost 5% of my production in a day, I would hit the floor. Like, that is a huge amount of fish. And they have the 5 million fish production at their facility. And what they were seeing in fish that weren't dead was most of the fish were very weak. They had spiral and side swimmers. They were not going on to feed. I mean, this is in that kind of 2-week period while fish are ponded, but not being fed feed yet. And what they ended up doing was suspecting thiamine deficiency. The veterinarians there suspected thiamine deficiency and gave these fry a bath in thiamine. And those fish turned around so quickly within an hour or two, were acting normal, no more spiral swimming, the mortality stopped, and those fish went on to feed. And so what they said was, holy moly, what happened in these spring Chinook? And so here's what we think happened. It really comes down to ocean conditions and climate change. And I think that that this can go along, Mark, with what you were asking about for wild fish. And there's really not going to be a reason why this would affect hatchery fish versus wild fish. Because in 2019, right, this red, hot and red part drove Chinook salmon to the shallow coast sooner and longer when they were in the ocean before they came up to the streams in the summer. And what that also did was that shifted in availability in their feed items. So instead of having this nice, cold, deep ocean water with their prey items to eat, they were forced to eat mostly bait fish, specifically anchovy. And like I said earlier in my talk, anchovy is a fish that is really high in thiaminase in their tissues. And animals that eat primarily anchovy can get their thiamine levels depleted. And that's kind of what they were seeing. So these adult salmon were hanging out in this coast here, and they were forced to eat anchovy versus anything else, which depleted their thiamine. And so those eggs were thiamine deficient as well. And I'll leave this here, but in 2020 last year, you know, I guess, you know, a question would be is, do we see this kind of gross mortality in steelhead? And I think the answer is no. We see a low smoldering failure to thrive in steelhead. But in 2020, what we did see within ODFW hatchery system is 2 or 3 groups of fall Chinook in Southern Oregon that presented exactly like this and were responsive to thiamine treatment in the fry, as well as coho in the Central Coast that were suffering as well and were completely responsive to thiamine treatment as fry. So I do think that we are seeing, and it might be underdiagnosed, but I do think that we are seeing clinical signs from thiamine deficiency in the fish that are coming up from the ocean waters in Oregon. And I don't see any particular reason why hatchery fish versus wild fish populations would have differing levels of thiamine in their eggs if they are eating similar prey or similar prey is available. And, you know, I don't see any reason why there would be differences, but I could see that this is why some years it could be bad. Some years we don't detect it at all. It also could be why we're seeing this more now and hadn't seen it before, or we just weren't paying close enough attention before to saying, oh, well, this was just failure to thrive. Oh, well, the fish just didn't do well. Oh, well, there's always another reason, or this female was bad, or there was some weird genetics here. As to brush it off as to why we're seeing some low-grade mortality in these fish. I think that thiamine could be really important in propagating fish in Oregon in the future. I think it could be crucial for how fish do while they're in ODFW's care. And I think that it could become standard of care to provide thiamine supplementation to fish that we're propagating in Oregon, and could play a really big part as to why stocks are starting to suffer, you know, wild stocks in Oregon in the future. I think I'm done.
Oh, that was great, Amy. Thank you. And for those of you on the board, this was really a classic example of operational research that we had talked about earlier, which goes to trying to improve hatchery practices. So very important function from OHRC, and Amy, thank you for your work.
Brad, I wanted to bring up that when they were talking about testing wild fish, that there are several hatcheries on the Oregon coast that use wild brood stock. in their hatchery program, and they could get wild eggs through those programs.
Good suggestion, Jack. Yeah, you bet.
Yeah, and we have, last year we did 2019, we collected 3 stocks of eggs, and that was just a quick little peek-see. 2020, we collected a lot of stocks of eggs. I think we have maybe 22 stocks that we collected and submitted, and so some of those may include wild stocks. And so those results are just, we're just waiting for the pandemic to open up the laboratories a little bit more so we can get those results, but I'm very anxious for those results.
There's also tons of room for experimentation in terms of how to deliver the niacin to eggs via immersion. Lots of variables that could differ between hatcheries and that could be tested real easily at the OHRC.
Any other comments for Amy? Well, we are right.
I hope we can continue to follow up our conversations on this, Amy. I agree with Carl's comment there. This is great work to host out at the center.
Well, we're right on schedule. And so if we were in person, we'd be taking a restroom break right now. But since we're not, we'll be trekking on ahead. Did I hear somebody trying to get another comment in there for Amy? No? Okay. So we'll introduce Megan Howell now to give us a presentation on the performance of the hatch boxes at OHRC. Megan.
Hello, good morning. Okay, 1 second. I'm going to share my screen. And
maybe Megan, while you get set up, I'll just say a few words. Board members will recall that I believe it was in early 2020, we brought a proposal before the board for research to be carried out in the simulated streams out at the OHRC to evaluate the performance of hatch boxes and stream side incubators. And Megan took that project on as part of her thesis in the bioresource research program at Oregon State University. And I have served as co-mentor along with Jim Peterson for that project. And Megan presented her thesis work on campus, 2 weeks ago now, Megan? And I think you're in for a real treat here today. So with that, I'll turn the microphone back to you.
Okay, thank you for the introduction, Mark. So I'm really happy to share this with you all. It definitely has been a lot of work, and I think we've got some really interesting results. As I'm sure all researchers can agree, it's really hard to condense entire research projects down into only 10 or 15 minutes or so. So I'm going to do my best. I think the important meat of this research lies towards the end with some of the discussion points and in the results. So I just want to give you a really brief introduction and introduce the importance of this research and a little bit of how we did it. And then I want to just move to the important parts and leave some room for discussion and questions and things like that. So with that being said, I'm just going to jump in. So I apologize if this is redundant information, but I just want to make sure that we're all on the same page as I move throughout the presentation. So supplementation, it's the production of hatchery fish intended to boost the abundance of naturally spawning fish. It's typically used as a conservation tool to boost abundance of naturally spawning fish. So hatchery conditions increase survival during those early life stages, and therefore able to produce many more juvenile salmon than what's produced naturally. These programs are considered successful for this reason, especially when supplementation efforts are combined with other efforts such as habitat restoration. Unfortunately, despite their success in producing so many fish, current captive conditions are controversial as they lead to lifelong divergence in vital traits, and this substantially lowers levels of fitness. So current hatchery reared fish live in raceways or stacks with little to no structure. They swim in circles, they are fed at regular intervals, and they don't experience natural predators. So the rearing of salmon until the smolt stage removes any opportunities for natural selection to select for traits beneficial for in-stream survival as fry. So this reason, coupled with the continual decline of salmon species, has prompted researchers to begin looking for alternative technologies for rearing salmon. So I'll introduce you to two. So here we have the Jordan Scotty Hatchbox and the Red Zone Streamside Incubator. So on-site or in-stream incubation of artificially fertilized salmon eggs could offer a low-cost alternative to hatchery rearing. Because these methods involve rearing salmon in the stream and therefore have lower levels of exposure to hatchery conditions, salmon reared using these methods could have improved adaptation to natural conditions and potentially higher levels of fitness. But despite these potential advantages, there isn't a lot of information available surrounding the egg to fry survival rates or the costs associated with rearing fry using these methods. So in order to fill in some of these gaps, we asked the question, how do Jordan Scotty Hatchboxes and Red Zone Streamside Incubators perform? So we measured performance in terms of the cost to rear a single fry, also known as marginal gain, the egg to fry survival rate, and mean fry size. So I'll just describe each of these a little bit more. So here we have the Jordan Scotty Hatchbox. It consists of 5 trays, and each one has 200 individual chambers for a single egg in each chamber. And each chamber has a small exit hole on the back. So these trays are loaded with the eggs assembled together using nylon ties and bolts. And then the hatchbox is placed into the gravel of the stream bed and left alone until all of the fry have left and you're ready to remove them from the stream. Here are some photos of them in action. So here's the loading tool that we use to load them. The holes in this loading tool were actually too small for the eggs. So we had to use a drill press to make the holes a little bit bigger. And even then they were still kind of too small, but we did make it work. And then here's a picture of one assembled together and a photo of one installed in the stream. As you can see in the photo, we put them in milk crates, and that's because manufacturer recommended installation doesn't include the use of milk crates, but there's been studies that show the milk crates help reduce sedimentation. And so we didn't want sediment to suffocate the eggs, so we put them in the milk crates. And then we also put rocks on top to keep the hatch boxes from floating away. And after that, we really didn't touch them again until the end of our study. Jordan Scotty sells these for $45 per hatch box. And then next we have the incubators. So instead of being installed directly into the streams like the hatch boxes are, the incubators are installed stream side. So a pump in the stream feeds water into the bottom of the incubator and it comes back out the top. They can be used with either freshly fertilized or eyed eggs, but in our study, we used eyed eggs for both devices. There is a slotted grate inside the incubator with a bag of plastic mesh below it. And so the eggs sit on top of the grate until they hatch. Then they'll go through the slots into the plastic mesh below where they develop and absorb their yolk sacs. And then after they're able to swim up, they come back through the slotted grate out the top of the incubator and into the stream. And then here are some photos of this one. So we placed the incubator on top of these wooden bases to prevent them from sliding and to keep them level. Here's a photo looking down into it. So you can see the slotted grate and it looks like there's some hatched alevins in there as well. And then I just included this photo so you could see that there is a gate that prevents them from leaving if you don't want them to. But in our study, we pulled the gate. We didn't see a need to keep them in for any longer than we needed to. And so here is an aerial photo of the artificial stream channels at the OHRC, just in case there's anyone who's unfamiliar with them. This photo shows only 2 running stream channels, but in our study, all 4 were running and they were all exactly identical with 4 pools and 5 ripples. So the channels are fed by water from Fall Creek, which comes in on this side and leaves here with screens on both sides to prevent the entrance or exit of fish or other aquatic organisms. The water also crosses a settling pond before it's pumped into the channels to avoid the buildup of sediment. So we alternated the treatments between the channels. The incubators were placed into the second pool of the first and third channel, and then 15 hatch boxes were installed into channels 2 and 4 with 2 hatch boxes in each pool, except the top pool of channel 4 just because of the odd number of boxes. We filled each incubator with 7,500 eggs, and then each hatch box with 1,000 eggs for a total of 30,000 eggs in our study. So in order to answer our questions about egg to fry survival, we used mark and recapture methods to estimate abundance in all the stream channels. So mark and recapture methods are used to estimate the number of individuals when counting every single one is impractical. So in our case, and I'm sure Jen can agree with me, catching and counting every single fish would have been extremely difficult and time intensive. So instead of that, we captured some of them from the stream, marked them, and then returned them. And then we came back to capture a bunch more, and we were able to use a ratio of marked and unmarked fish to estimate the total number of fish in each stream. So on the first day, we removed and marked 10 fish from each pool for a total of 40 fish from each stream. So we used a dip net to do this, as seen in the photo on the right. And traditionally, the adipose fin is clipped for marking, but since these fry had such small adipose fins, we chose to clip the lower lobe of the caudal fin instead. And then each fry was returned to their respective channels and left overnight. And here's just so you can see the tail where we clipped. And then on the second day, we electrofished the stream channels and removed all the fish that we caught. So we made 10-minute passes from the bottom to the top of each stream channel and then repeated this process for a total of 2 passes per channel. We removed all the fish we captured throughout this process and then later counted all the marked and unmarked fish from each channel. And we also collected length and weight data from a representative sample in each channel. So we used a data set of 950 Chinook salmon fry lengths in spawning areas from the Willamette to the Clackamas to perform a power analysis and figure out how many fish we needed to measure for this. And we found that with 95% confidence, we needed to measure 40 fish from each channel. So we measured fork lengths, which is the length from the tip of the snout to the fork of the tail. And then we also measured weight using a scale. And then finally, we were able to determine if fry produced by either device were longer or heavier, analyzing all this data. So here's our survival rates by stream channel. So the hatchbox channels are the blue bars and the incubator channels are the gray bars. The incubators had survival rates ranging from 59 to 77%, and the hatchbox streams had survival rates between 73 and 85%. So taking into consideration that the hatchbox channels had survival rates significantly higher than the incubators, you probably won't be surprised by our abundance estimates, which are here. So if you remember, each stream was loaded with 7,000 to 8,000 eggs, and we estimated that each stream had anywhere from 4,400 to 6,800 fry at the end of our study. The incubators actually produced 11% fewer fry than the hatchboxes did. So while 11% may not seem like a huge difference or look like it from this graph, but when we think about this difference in the context of the millions and millions of fish that hatcheries produce each year, that really does add up quickly. It's an extra 110,000 dead fish for every million produced, which is not only financially strenuous, but would also require a lot more fertilized eggs and a lot more work for hatcheries. And then we also found significant differences in mean length. So the fry produced by the hatch boxes were 6.8% longer on average than the fry produced by the incubators. And then we produced this box plot of residuals as a way to determine if there's any raceway effects. So a raceway effect, or also known as a tank effect, would occur if there was some reason why we saw differences in length or weight that we didn't account for or weren't actually from our treatments. This is a lot more common in lab settings. Luckily, our box plot shows that we didn't have any raceway effects, so we can be confident in these results. And then we also found significant weight differences. So the hatchbox fry were 21.4% heavier than the incubator fry. I also included the box plot that we used to indicate there is no raceway effects that had an impact on fry weight. So while these differences are significant, it's important to consider these results in terms of real life application. So even though the hatchbox fry were 6 to 20% longer and heavier, the actual difference of a few millimeters or grams might not be enough to actually impact their survival. So these results really did raise a giant question. Why did the hatchbox streams produce larger fish with higher survival rates? And while I don't have a definitive answer to this question, I do have a hypothesis. I believe the fry produced by the hatch boxes were able to exit the device into the streams sooner than the fry produced by the incubators. So when I went up to take data, I noticed that some of the fish in the incubators had absorbed their yolk sacs, but were still on top of that slotted grate swimming around. And I don't know how long those fish were inside the incubator, but I do know they wouldn't have been eating during this time when their equally developed hatchbox counterpart would have been in the streams finding food and growing. I'm guessing this is probably why the hatchboxes had higher survival rates too. They weren't hungry and weak when coming out of their device, and they were able to survive in the natural conditions better than the incubator fry. And then we also noticed some really odd mortality during this experiment, which I'm guessing may have also been due to this. So as you can see in this photo here, we found what looks like a pile of dead fry on the bottom of the incubator stream. At the time, we had no idea why this would happen. Fry don't just group together and simultaneously die, so that's definitely not what happened. Part of me wonders if these fry swam up to the incubator, or they didn't swim up to the top to be pumped into the stream before they starved. So maybe they died, floated to the top, and were pumped out. And then because they're similar size and weight, they just floated downstream and landed in a similar area. Either way, there was some really odd death happening in the incubator channels. And finally, here's some results regarding our cost per fry. So for the incubators, we included the purchase price of $1,877, paying someone minimum hourly wage of $12 an hour to install it and maintain it. The pumps for the incubators had to be cleaned off occasionally, and the incubators needed to be purged of sediments a few times. So this means someone needed to pull a specific valve that shoots water out from the bottom instead of the top to get rid of anything lingering in the bottom of the incubator. So the incubators ended up producing a single fry for about 5.5 cents. The hatchbox calculation includes the purchase price of $45, paying someone $12 an hour again to install them, and no maintenance costs as we just left them for the entire experiment. So the hatchboxes were able to produce a single fry for about 6.5 cents. And again, this difference may not seem large, but when we start talking about the millions and millions of fish, that one set difference really does make a big impact. Since supplementation programs aim to restore the natural production of salmon populations, efforts to produce juvenile fish are only meaningful if they lead to the return of adult spawners. So essentially, this means that we can produce all the juvenile fish we want, but if those fish don't return to contribute to future generations, then our supplementation efforts weren't successful. While making definitive calculations is hard, we can use information from across several studies to make estimations about relative costs. So here we showed that a single fry can be reared for about 6.5 cents. A particular study found that unfed coho fry have a survival rate of about 0.09%. So unfed means the hatchery did not supply food to them, and these fish had to find food on their own, similar to in our study. So while the fry to adult survival rate of coho might differ slightly from Chinook, we can still get an approximate cost to produce a single adult returner of about $66.67 after releasing 1,100 fry. On the other hand, smolts released by hatcheries have a survival rate of 2.55%, although they need to be cared for much longer, so they cost about 74 cents each. This means the cost to produce a single adult returner using traditional hatchery methods is around $29.14, and we would need to produce around 40 smolts for each adult returner. However, the quality of fry produced through these methods might be significantly higher than those produced using traditional hatchery methods due to that reduced exposure to hatchery conditions. This is important because we don't want to lower the level of fitness in wild salmon populations through genetic contamination from hatchery fish. So despite their higher egg to fry survival rate, there are a few surprises and limitations I believe are important to include about the hatch boxes. So first, from a random sample of 100 fish, we found 3.5% of the hatchbox fry had a deformity in their tail. The upper lobe of the caudal fin was folded downward. So we first noticed it when we removed some of the fry to clip fins, and I noticed it a lot more when counting electrofish fry. We also found an average of 62 dead fry in each hatch box when we removed them from the streams. So this is more than 6% of the eggs in each hatch box dead. And most of these dead fish we found were like the ones on the image in the right. They had hatched, absorbed their yolk sacs, but they were unable to leave through the exit holes. And there was even a few still alive and stuck inside. So this is troublesome for a few reasons. The first reason is that the hatch boxes could have had a much better egg to fry survival rate if that 6% had been able to leave the box. And that really does make a big dent. And the other reason is that this raises ethical concerns. So the fry that were trapped in the hatch box had absorbed their yolk sacs and were probably unable to swim or find food for as long as 4 weeks, which nobody wants to see that happen. But on that note, I also want to touch on the applicability of the hatch boxes. So they may not need power, but they do take time and energy to install. So someone has to be digging holes in the riverbed to install these. And I can tell you, as the person who did it 15 times, I don't really want to do it much more. They also take a really long time to load, as an egg has to be placed into 200 chambers 5 times to complete even one hatch box. And we had to be really careful not to accidentally get 2 eggs into one chamber, because then it was really tricky to get it out without squishing eggs or without dumping it over and just completely starting again. So to make a significant contribution and to even close to what an incubator could, if you remember the hatch boxes hold 1,000 eggs and the incubators can hold 100,000 eggs, we'd need to install quite a lot of these. And that might not be reasonable considering how much time and space it would take. Also, they can get away if they're not secured well because they float. So it's happened to other researchers, and while that's a loss of $45 and some eggs, it's also plastic pollution that goes down the rivers towards the ocean. And then I also think it's important to talk a little bit about the applicability of the incubators. So while they can hold a lot more eggs than the hatch boxes can, this device requires constant water flow from a pump. We lost power 3 times throughout this test, which caused all the water to flow out of the incubators. So the installation of alarms and the presence of staff on site 24/7 to immediately correct power loss issues prevented mortality in our study, but power loss incidents in areas without that 24/7 supervision could result in complete mortality. And the use of gravity-fed pump systems might minimize this issue by removing the need for power, but even those aren't effective 100% of the time. So despite their success in producing many fry, these technologies don't address the underlying reasons for population decline. So they might be useful for making contributions in locations where wild populations are critically endangered, but they don't correct issues surrounding habitat degradation, overexploitation, or migratory route blockage. In fact, concerns surrounding supplementation, such as genetic contamination, disease transmission, and competition between hatchery and wild fish, might be exacerbated using these methods due to the large quantity of hatchery fish in streams. So although they don't correct the causes of salmon population decline, I do want to say that they might be useful conservation tools in some situations. So for example, they might be useful for contributing large quantities of fish in areas where natural populations are low. And they could also help to alleviate some fitness-related risks that hatchery fish pose to wild populations. So with the decline of important salmon species, conservationists and managers should consider the application of alternative rearing methods like in-stream hatch boxes and streamside incubators. Although they don't correct the causes of salmon population decline, they might be useful conservation tools in some situations. In addition, these methods aren't more cost-effective than traditional hatchery methods. However, the quality of these fish produced by the on-site incubation methods might be higher than those produced in hatcheries. So for all these reasons, we recommend that managers consider their goals carefully when making decisions regarding the propagation of hatchery fish. And then there's just a few acknowledgements that I wanted to include on this slide. All of these people, and again, everyone on the board and everyone here today, you guys all helped us get through all of the challenges of this research with COVID and in-water work and threats of a landslide and fires from last summer and so much more. I hope I didn't go over by too much, but with all of that being said, I'm excited to answer any questions that anyone has.
All right, thanks so much, Megan. That was really interesting. And I think we've got time for maybe a question or two. We're running a little behind, but I can talk faster during the next segment.
Sorry.
No, not a problem. And again, you know, you've taken only what, about 15 minutes to talk about what has been an effort that we envisioned back in 2019, right? We started putting this together. The board had a chance to approve the proposal for the work. And then Megan has been driving out to the OHRC every single week through the course of this research. Everybody masking up and getting it done, bringing eggs in from Elk River. There's just been a tremendous number of obstacles. And again, it's been a huge effort, all to boil into a 15-minute presentation. So certainly you deserve a few questions from the board. So
looks like Andrew has his hand raised.
Yeah, thanks, Fred. Megan, thanks for a great presentation and some really interesting research. Thanks for sharing. Really appreciate it. My question is, and I apologize, I was having some technical issues when you were at the start of your presentation when you were talking about research design and so on. So I was wondering if specifically with the hatch boxes, if you saw any correlation between productivity and growth or not relative to where they were located in the stream and potentially sort of varying stream conditions where those boxes were located.
Yeah, thank you so much for asking that. That's something else that Mark and I are continuing to look at. We do have data for flow and oxygen and temperature at each individual hatch box throughout this study. And we also recorded depth of each hatch box at the end. And so we are still looking at that data and running some analysis to see how those things impacted survival in individual hatch boxes. So I wish I had an answer for you right now, but we're still looking at that.
No, that's great. Thanks. Look forward to learning more when the time comes. Thanks.
Yeah, I can tell you off the top of my head, we did notice that the hatch boxes that were a little bit deeper had a little bit more mortality in them. But I don't know exactly how much yet.
Thank you.
Megan, was the brood that you guys used for all these studies, were these hatchery origin females or were they natural origin spawners?
Yeah, they are from the Elk River Hatchery.
And
all of the brood were hatchery origin, Brad.
Okay, thanks, Mark. So I guess maybe a follow-up study as we talk about future studies might be then to study the adults when they come back for fitness to see if the fitness has been improved through this kind of supplementation versus rearing them in the hatchery itself.
Yeah, definitely. There's a lot more research that definitely comes to mind for me from all of this, including seeing what you mentioned, as well as what sorts of effects that, let me see if I can find that slide. What effect this this tail folding has on the survival of those fry. And, you know, we need to see how the fitness rates of the fitness levels of the hatchbox and incubator fry really do turn out, because we can guess that they'll probably be higher, but right now we don't know.
Thank you.
And I'll just add that Megan has described all of this work in her thesis, and that is nearing completion. And when it is done and signed, I'll be happy to distribute it to everyone on the OHRC board.
Oh, outstanding.
Read.
Okay, so our next item is the evaluation process. And just for review, especially for you new board members, in March, we had the three primary investigators, the three PIs for three main strategic studies, not operational now, we're shifting gears to the strategic research, present how their studies are progressing and how they fit the mission statement. And then as board members, we went back to our collective homes and offices and used a form that Mark devised to evaluate each one of those studies. Those forms were submitted to me for recapping, and I submitted them to Mark in person. And then Mark's going to explain what those next steps were. I mean, that's kind of the end of my engagement, or the board's engagement on that process. But Scott and Jack and others today, when I said this feels like a new day to me, and in the past, the mission statement may not have mattered because they just wanted to study whatever they were going to study. Those are all legitimate concerns, you guys. But this does feel like a new day precisely because of what Mark's going to talk about right now. And that is the influence of you board members on the research, to prioritize the research. And you can do that through restricting funding for one or all of the studies. That certainly would prioritize the research, or addressing new ideas for research. And I know Mark's going to talk much more about that in the future as well. But this is it, you guys. I mean, this is the focus of the board, to basically prioritize and influence and direct the science that comes out of that building right there that you're looking at to fulfill its mission. So our board responsibility isn't necessarily parallel to the mission of the facility, but you have to keep in mind what that mission is. Our role is to be vociferous and to have ideas, to have thoughts, and to weigh in on this evaluation process. And so it's a new process. We're transitioning into it. There's bound to be hiccups, but you guys, if this doesn't give you a cause for excitement, I'm not sure anything will. This is a new day. So based on that introduction, Mark, spend as much time as you want to. This is an important deal right here.
Okay, thank you, Brad. I assume everyone can hear me and see my screen. Before I jump into the meat and potatoes of the presentation here about the evaluation and support for research at the OHRC, I do want to just take a moment and talk about a couple, just briefly talk about a couple of important scientific publications that you've seen one of which, and if I can get my screen to advance, the report by Ron Griffiths, who has been working out at the OHRC really since the center was founded. He worked closely with David Noakes and received a lot of support from our director to characterize the benthic macroinvertebrates in the simulated streams at the center, as well as the surrounding Fall Creek and its tributaries. And this is incredibly important work, and it relates to the presentation that you just saw by Megan. So when those fish came out of the hatch boxes, their next step in their life was to find food, and without macroinvertebrates, a food source in the stream channel, I think we would have lost them in large part. But Ron's work has shown us that the macroinvertebrate community in the stream channels at the OHRC is quite consistent through time and quite similar to the surrounding streams in Fall Creek. So if you haven't had a chance to take a look at that report, please do. I've been in continued communication with Ron, and he is keen to return back out to the OHRC when he can and follow up on this work, and also evaluate how the landslide might be affecting the insect community in the stream channels and surrounding Fall Creek as well. So that's important work. Take a look at the report if you haven't had a chance to. And then I'll also just briefly mention that Dr. Banks communicated to me yesterday, and I see Dr. Banks and Dr. Auld are both with us today. Great news that their new manuscript, or their manuscript entitled Differences in Mate Pairing of Hatchery Natural Origin Coho Salmon Inferred from Offspring Genotypes, quite a mouthful there. But I am super eager to read this paper, which I understand has now been accepted for publication in integrative organismal biology. Dr. Ald, would you like to say something about that paper, that manuscript?
Hi, sorry, am I off mute now?
We can hear you.
Okay, great. Yeah, so we're really excited that this paper received a lot of favorable reviews from both the peer reviewers and the editors. It has been the main focus of what we've been working on, and the results of this paper are what informed our wildlife mate pairings this past experimental season at Sandy Hatchery. So we're looking forward for everyone to be able to read this as well.
So this is the publication that'll tell us how hatchery and wild fish differ in their mate choices when they're out on spawning grounds. Is that correct?
That is correct.
Well, that should be an interesting read for everyone on the board, and look forward to seeing it in print, and we'll certainly get it distributed out to the board members when that time comes. So thank you.
Scott, if Mark, if I could just jump in quickly, I can't help but want to tell Scott that finally this paper will show you thousands of markers that we have identified to be engaged with the differences in mate choice decisions between hatchery and natural fish. You always asked, do you have the markers? Well, this is finally now blessed by peer review, and we're very excited to soon be able to share this with you all.
Okay, thank you, Michael. Looking forward to that, seeing that paper. It's an exciting accomplishment. Another quick note here in terms of outreach from the center. This is what our website currently looks like for the OHRC. I have been working with our informatics folks within ODFW to update the information on our page. And I'll show you here next that I'm also working to update the aesthetics and the visibility. So moving from a very text-heavy web page to a page with some buttons and larger images and a video that's already there, but it's sort of hidden off in a corner. So I've been working with the folks, our webmaster at ODFW, to update both the information and the appearance of the website. There are some constraints there, so we're not able to maybe make this as flashy as I might like, but I'm doing my best to push the envelope as best I can. So stay tuned for that. I expect that we'll have this new website up and running within a month's time. So jumping ahead now to talk a little bit about the research evaluation and support process that we've been going through here in 2021. So at the last board meeting, you were asked to engage in a new process. We had presentations, updates by all of our principal investigators. Then you as board members had the opportunity to evaluate that research using a standardized form. Right, so this is something that's completely new. And then those board rankings and comments came to ODFW, they came to me, and I met with folks within the agency and we discussed them. Now, this was a new process, and because it was a new process, and we're also, I would say, challenged by the online format that we've been forced into because of COVID safety precautions. You know, there's room for improvement. I recognize that, and I've heard some suggestions as to how we might improve this, and I welcome more of those suggestions. So I want to provide a better process for you to offer your views and opinions, because prioritizing research and evaluating research and coming up with new ideas, that is central to your duty as board members. All that said, the information that was generated through this process was really relatively easy for us to interpret and help to inform the research funding decisions that we've made at ODFW. Now, overall, we saw some support for all of the projects, but we also saw some calls for improvement. In short, because of that, ODFW decided to continue funding all of the projects, albeit at greatly reduced levels that we viewed as commensurate with the evaluation scores that you provided and your comments for each of the projects. So where projects were viewed very favorably, we provided more funding to those projects and less to those that appeared to need maybe a bit more redirection and focus. So as I said earlier today, ODFW is already committed to funding $635,000 toward continuing the research that is currently being conducted at the OHRC. But again, this leaves a cushion of about $400,000 of revenue that we project to collect through the course of the biennium. And that money too, as I mentioned earlier, will be used to support research at the OHRC. And so here's sort of the plan for how. Over the past few months, I've been working with my colleagues at OSU and at ODFW to develop a transparent and competitive process that will be used to review, prioritize, and fund research projects at the OHRC. And this is certainly something that's new. And what I'm talking about here is a process that would involve 5 fundamental steps. So first, this fall, I'd like to convene a workshop at the OHRC that'll bring together experts in the field of genetics, fish culture, ecology, hatchery research, and related fields to review our current projects and offer their opinions of our work, what we're doing, and identify other questions that might warrant our attention. So this will be a way in which we can get some outside opinions as to how we might redirect or refine focus of our ongoing research, as well as brainstorm and generate new questions and ideas. Now, of course, if members of this board have ideas for new research that serves the center's mission, you know, I certainly encourage you to communicate those to either the chair or myself. And it's, again, I'll just emphasize that this is absolutely your duty as board members to come up with new research ideas that serve the mission of the center. Following that workshop, which I hope to be able to hold in September, the OHRC would then announce a request for proposals. This is the second step of the process. So research proposals might be for either ongoing strategic or operational research or new operational or strategic research. But in all cases, you know, successful research proposals will serve to support the mission of the OHRC. This research or RFP process will have a deadline for this first round, and I'll talk more about why I say first round here. That deadline will probably be in late October or early November. We're shaping this up. It's evolving as we speak. Now, at this time, I will distribute all of the proposals to an independent science panel for review. And this is something that Dr. Selena Happel at OSU has agreed to help me to pull together. And then I'll forward the comments from that independent scientific panel along with the proposals to this board. And you'll have the opportunity to review all of that information, the research proposals, as well as the review comments from our independent scientific panel. Then you'll have the opportunity to discuss the proposals and rank them at our meeting in December. See, that would be the 4th step. And you'll be able to discuss and prioritize that work for the center. The last and the fifth step in this process will be that ODFW will then decide which projects will receive, funding, and we'll make those commitments and develop new amendments to support either an expansion of our existing and ongoing research or new projects that are identified and prioritized through the review process. Now, I envision this to be the start of a regular proposal review cycle associated with our biennial funding cycle. And I've sketched out a diagram of how this cycle might look. Let's see if I can bring that up. And I'm working with my colleagues at OSU and ODFW to refine this schedule. So this may be a little bit small on your screen. I hope you can see it. But right now, and we're sort of off schedule in a year because we're getting this going, but this would be sort of the longer term vision for this process. So right now we would be sort of in an odd year, but we're actually reviewing and getting things going, but sort of speaking in circles here. But over the longer term, where, let's see, we would begin, it's a cycle. So where do we begin? In an odd year, we would discuss funding decisions, which is sort of what we're doing now at the end of this year. Then in the June board meeting, we would get updates from researchers. We would evaluate research, and then we would again have a call for proposals in the even year, receive those proposals, review them with a scientific panel, bring those reviews back to you, allow you to prioritize the work that's been proposed, and then in the odd year, again, make funding decisions at the beginning of the odd year, not at the end as we're doing here. We're having to adjust this a little bit because this is a new process and we're sort of off step, but I envision this as being something that we can continue into the future and that will expand our scope of work at the OHRC and provide a very transparent and systematic way of evaluating and supporting research at the center. And so maybe I'll stop there and we can back up or move forward. I would imagine this is new to most everyone here and that you might have some questions.
Hey, Mark, this is Carl. I like the idea of the workshop. And in this scheme that you have here, would there be a workshop every other year? Or have you considered the possibility of sort of a sea grant approach where you could solicit pre-proposals and have a panel review pre-proposals and then jump into this kind of program?
Right, Carl. So first of all, I'll say that this is a sketch and a concept at this point, but it's one that, you know, I'm scrambling and working quickly to flesh out. And so all ideas are still welcome at this point. Nothing here has been carved in stone. I personally would not see the need for regular workshops, right? This year we're hosting, my plan is to host a workshop to generate a list of ideas, right? That we can, and these are questions and research concepts that we can then prioritize and rank and establish which of these do we view as the best and most important. And those can then be communicated to the scientific community as part of the RFP, right? So folks can see what are our questions and then they can shape their research proposals to address those questions. Moving forward into the future, I believe that this board can generate those questions, ODFW can generate those questions, or we can work through our list of questions that we attain through this workshop. But I don't see, at least at this time, a need for annual or biannual workshops. There may come a time when we'll need to do this again, and we'll certainly learn from the process that we're going through this time. And I would certainly appreciate any advice and assistance you might offer in pulling this workshop together, other board members as well. We've got an awful lot to do to make all of this happen. Lots of ducks to line up, but all of the PIs, I believe, are now familiar with this process. This provides an opportunity for them to present their ideas in front of a broader scientific community. We can talk about opportunities for redirection or refined focus, and then we can assign funding as appropriate following that, and seeing how they might shape their proposals, and at the same time bring in new proposals that we can consider for prioritization.
Yeah, I asked the question because I agree with everything you said. Seems to me like you could also have an infusion of other ideas in years to come by sending to the scientific community and also sister agencies and so forth in other states or whatever. But the questions are that the OHRC is trying to answer, and then getting input. That's why I'm suggesting something like a pre-proposal, so somebody's not writing spending half a year writing a NSF type of proposal, but 2 or 3 pages saying, here's how I would address your question. Then that'd be something for the board then to look at.
Absolutely. I really like the approach of a pre-proposal program. It makes great sense from the researcher's perspective because time is a valuable resource. Are there other questions or comments from the board? And I'd also welcome comments about any thoughts that you might want to share about the evaluation process. So we put together that form to help you offer your views of our ongoing research. Was that an effective process in your view? And what might we do to improve it? I'd either here or after the meeting, I'd be keen to hear your thoughts on that. Because I think that process will be built into this cycle. We'll be regularly evaluating the research that we're doing, as well as reviewing new research proposals.
Mark, this is Andrew. Thanks for the presentation. I would just echo Carl's comments. I agree with a pre-proposal approach. I do that at OWEB in a number of different granting programs and find it very effective in just providing guidance at that earlier stage. I think when the proposals are fully developed, you have just a better product and creates better expectations both among the I guess I don't want to say applicants, but the PIs and as well as the board in terms of what ultimately the project would include and some of the considerations around cost benefit and cost effectiveness and so on. And so would just further emphasize I agree with the pre-proposal approach. And I think you just answered my question too, which was part of this evaluative process included providing I guess constructive criticism to the PIs for the ongoing research. And as you described, reduction in funding. And so I just think it's important too that this review process includes a mechanism to continue evaluating those projects so that this board is able to provide guidance in follow-up to those evaluations to help those PIs adjust their efforts as needed to make sure that they're fitting within what the board is looking for. And I guess one thought too is just, and maybe it's a concern, I don't know, a question or concern, but the idea that at a reduced level of funding, will those PIs be able to make those adjustments that this board is looking for? And then also just your thoughts on ensuring that also at a reduced level of funding, we're not diminishing the ability of those PIs to complete the projects in a way that, you know, that would diminish the past investments made to date. I mean, can they still accomplish the work at a reduced rate of funding? So sorry, kind of a lot there, but just some thoughts to share.
No, it's a good question, and I think it deserves maybe some clarification. So starting out beginning in July 1st, the PIs have been promised and will receive funding for their projects. But as I stated earlier, and you've reiterated, at a reduced level. That level is where we're starting. That is not to say that and it should get them through. I've been engaged with all the PIs to make sure that that level of funding can get them through this process at the beginning of this biennium, right? They can keep their staff going. They can initiate their experiments, but it may not get them to the end of this biennium. But through the process, we'll have the opportunity to review the approach, review the scientific experimental designs, be able to adjust them, or we might, through this review process, say, look, this work doesn't offer enough promise, and we've got another idea that looks better now. And so we can actually take this as an opportunity to shift our focus to that other direction, if that appears to be the better way to go. Or if in fact we see, hey, look, no, this is the best path, and this PI needs more support, then we can expand that support and therefore bring that project to full fruition. So
thanks, Mark. That's super helpful.
Yeah. So it's a way of reserving commitment at the beginning so that we can preserve our flexibility to shift or shift our focus if we need to. It's a different process. We have not done this before. It's a lot of change, and I'll say again, there's an awful lot to line up here to make this work. So I'll be scrambling, and again, we'll appreciate support from folks like yourself, Andrew, board members, that can help me to flesh out this process. Please get in touch with me after the meeting, and we've got work to do.
So I think, Mark, it might be helpful if we can get together and schedule that September meeting after your workshop. And I'm hopeful. I may be out of town early in September to watch my granddaughter. She plays college volleyball, and she's got an important tournament on the East Coast. But I'm hopeful that I'll be here for that. I would greatly love to be part of that workshop. I'm really hopeful that every one of the board members, the voting board members, certainly would want to be part of that workshop as well. But I'm guessing maybe we should schedule the board meeting, and gosh, I'm hopeful that that can be at the facility as well, in person, in September after this workshop. If that means we're not going to be the second, Tuesday of September, so be it. Maybe it'll be the 3rd September or something like that, so that we can have this workshop first to have the discussion at the board meeting. And Andrew, just to circle back, and I'm not picking on you, but you did make a comment that we need to kind of free ourselves from. And that was, we've got a lot invested in these 3 projects. I interpreted what you started to say, that so that we don't waste that investment, we keep investing. No. In the real world, your first loss is your cheapest. So if you get to a point where you're developing a product and you realize it's not going to meet the market demand, you cut the funding immediately to that. So we need to free ourselves from that thought that, hey, you guys, we've invested a ton of money in these 3 projects. We have to keep investing. Nope. If we come to the conclusion, Andrew, that that's not going to get us to the mission, and again, the mission, the cure for science, is improving the fitness of hatchery fish. period. I mean, Sean could not have said that better in his opening comments today. That's the mission. And if a study is not going to get us there, then the funding is going to be reduced. And that's part of that prioritizing process that is going to happen in that September workshop, or as a result of that September workshop.
Yes, thanks, Brad. If I could comment, I totally appreciate that and agree. I think that's really an important consideration. The other thing, though, that I think about is research takes time, and there was a point at which this board, and maybe it was a different composition of board members, approved the research with the associated timelines. And so just want to be considerate of or conscientious of those timelines and what the research objectives are, at the same time that we're also evaluating, are we getting to those objectives? So just thinking about timelines too, in that same sort of calculus.
Mark, can you hear me? This is Chuck.
Hi, Chuck. You bet I can hear you clearly.
Finally, I've been screaming at this microphone most of the morning. Hey, I am disappointed by the support and participation by the board. And I think a lot of that is to blame on our meetings, the way they're set up. This Zoom is a pain, you know where. And I think we need to go back to at least some of the meetings where we meet somewhere, whether it be Salem or the OHRC or wherever. I think we would have more participation by the board.
Chuck, I hear you loud and clear, and I absolutely agree. I have been asking those questions of our leadership within ODFW. When can we return? My understanding is it's still an open question, but I am hopeful that by September we can bring this board together in person. And I encourage everyone to please do that safely. We'll have to. That's our first priority, but certainly I look forward to having these meetings in person once again. I think it would allow us more time and more opportunity to interact on a deeper level. So again, I hear you loud and clear, and I will be, I'll continue to ask those questions. And as soon as we can get together in person, I will let everyone on this board know.
That's great. Thank you.
Yes. The Zoom meetings are difficult for me too.
Well, you don't know what difficult is until you're 75 and deaf, right, Carl?
Is Lance, Lance, are you on this call? I'd like to hear from you if you are. I know you were going to be late because you had another meeting that you had to go to. But if you
Brad, I'm here.
Yeah, if you could weigh in on the process and just kind of what you've heard today, I'd sure appreciate it.
Yeah, I think it all makes sense, and that the science workshop in September, I think, will be very valuable in providing some fresh thoughts and ideas. So support that completely. But yeah, I'll follow up with some more thoughts formally with Mark.
Yeah, great. And I know with your resources that you could have some really, I think, viable research ideas or suggestions too. So I hope that you can be a big going forward for sure. And then Travis, you're brand new to the board. Marine was just really an important resource for us. I mean, the tribes, gosh, I have so much respect for what the tribes are doing, and some of the science that they're doing is leading edge science. And she from time to time did share some of those ideas and thoughts, and those helped to inform our mission here on the board. She may have been more shy about doing that than I would have liked to have seen. So I want to encourage you at any moment, at any time, in any form, in any way you want, to please help inform the direction we're going based on the science that the tribes are doing.
And Mr. Chair, I'll
I appreciate
add,
those words. It's definitely something I hope to do as part of the board.
Great, thank you. And then Dwight, are you still part? In fact, actually, I'm not even sure, Carrie, if Dwight signed in for this meeting or not. But Dwight, I'd like to hear some comments from you, if I may. Didn't think so. Okay.
Mr. Chair, I do believe we're joined earlier also by Derek Wall, who I believe is still on the call, joining us from Bristol Bay.
Oh, great, great. Yeah, Derek, feel free. This is your opportunity to share some thoughts about the board and kind of what you heard today, primarily about the mission statement and the science evaluation process.
Yeah, can you hear me?
We can.
Hey, yeah, I'm excited that I was able to get in. Still kind of trying to wrap my head around the whole process. I wish I could have seen that evaluation form maybe, but I'm sure I can still get that. Yeah, you know, being a fisherman, commercial fisherman, you know, increasing the vitality of hatchery fish is pretty crucial to us in their return to the rivers. So, you know, I'm still trying to soak it all in and wrap my head around the whole process, but it's very exciting.
Great, thank you. We're looking forward to your contributions for sure. Boy, Mark, I may be out of bullets here. I mean, do you have anything you'd like to share here at the end of the meeting, or directions for September or this upcoming workshop? I think the board can probably expect some kind of communication probably from your office as we move forward. There's a big void here in time between our meeting now and September. That workshop is critically important. So I'm hoping that you'll keep us all apprised as a board. Certainly as you get Dr. Banks's study, you know, we want to see that presented as well. So you guys look for your inboxes, because there's probably going to be, even though it's not a formal meeting, there's bound to be a lot of awfully important information coming your way.
Absolutely. I said it earlier, we've got a lot to do here in the next few months to make all of this work. And piled on top of that, I am involved with the amendments to the contracts that keep our current work going as we start the new biennium on July 1st. So there's a lot moving forward here, as well as the science that'll be coming out from all the PIs, the paper on radio telemetry in the Elk River carried out by the olfactory and printing team. That is now in final form online, and I can distribute that to the board, although I think you've seen an earlier version of it. Dr. Banks and Dr. Ald's paper, I'm excited to see. And then, yes, there'll be a number of updates on process as we approach that September meeting. There'll be a lot to do, so please keep an eye on your email. You'll be hearing from us. And we've done a great job working through the agenda. It was a lot to cover today, and we're close to our time, but I have nothing more from me.
Okay, great. Hey, thanks again for everything you've done, Mark. I mean, most of this process was definitely through your hard work. Is there a motion to adjourn?
I'll make a motion to adjourn.
Thanks, Jack. Is there a second? All in favor? Aye. Hearing no objections, the meeting is adjourned. Thanks, guys and gals.
Thanks, everyone.
Thank you.
Thank you all.
Thanks, guys and gals.
Carolyn, ready to turn this off.
Apparently your stuff got moved on.